Hi calculus student, this video is for 3.9 part 3, the last part of finding derivative of exponential and log functions. So in this particular one we are looking at a techniques of differentiation called logarithmic differentiations. So you might say, Ms. Chen, we already know how to do log differentiation, which is 1 over x if it is ln, and if it's 1 over x times ln b if it is other base. But this is actually something else. The name itself sounds a little funny because usually when we say we do derivative of log, we say differentiation rule of log, but this is a technique that's called logarithmic differentiation. That means if you have something that has no law, no, in the form of where the base is a variable, like x to the x. This is a variable, kind of like the polynomial, but then instead of x cubed or x4 or x1 half, the exponent is a variable. So what rule do I use? Do I use power rule or do I use exponential rule where I treat this as a base? I mean, how do we do this? So there are quite a number of a function that would be in this particular form, not just x to the x. It could be y equal to like sine x to the x. So sine x is itself is a function, and then the exponent is a function. So for this kind of function, we would use something called logarithmic differentiation. So here are the steps. The steps would be we take natural log on both sides, and then we use property of log to expand ln h of x. That means the left hand side, and then we differentiate. I think this is the right hand side. So what we're talking about is y equal to h of x. So if we do h of x will be these complex things, and then we expand it so that this would become a coefficient, and then we differentiate both sides. But the left hand side dy dx, because it would become ln y equal to ln of h of x, right? Both of these so this one is you have to do a change, you have to do implicit differentiation, it become 1 over y dy dx, and this side would be, do the expansion, and then you multiply because you automatically only want dy dx, so you multiply both sides to get dy dx, and you replace your y by h of x. So the steps sounds very cryptic, so let's just do one so you will understand what I'm talking about. So this is y equal to x to the x. The base is a variable. The exponent is a variable. There's no rule that can do this. So what we do, the first step is we add ln on both sides. So we ln y on this side, on the left hand side, and on the right hand side I have ln x to the x. Because of log properties, whenever this x is an exponent, whether it is a variable or not a variable, I can move it as a coefficient. So I would still have ln y. I expand this by log property, become x ln x, right? X ln x. It was x to the x, but after I add ln, I can change into x ln x. Now I'm going to do d dx on both sides. Ln y equal to d dx of x ln x. Now this I have to change the x into y because my expression that I want to do derivative with has only y, so I do dy, and then this is ln y times dy dx, kind of like the fraction. I change it to y. Original is x, so I have to have a dy dx at the back. This is a product rule. X is f, g is ln. I think we did this earlier. So f prime is 1. G prime is 1 over x. So when I do a derivative of it, so fake 1 times ln x minus, plus fake 1 over x times x. 1 over x times x. It's just 1, right? So it's equal to ln x plus 1. And the other side would be dy ln y would be 1 over y dy dx. So equal to ln x plus 1. Okay. So then I need to continue. Okay, not enough space. So, but then what is dy dx? I only want dy dx. So it would say dy dx would equal to y times this whole thing. I multiply y on both sides. So y. But what was y? Y is x to the x. Y times ln x plus 1. But in terms of x, it will be x to the x ln x plus 1. And that is the answer for the derivative. So see, step 1, I look at the steps again. I take natural log on both sides. Step 2, I differentiate both sides. So these are the using implicit. Okay. So you after you take log, you expand the left hand side so that it becomes x ln x, and then this is just doing derivative product rule or whatever. This is the implicit. And then you multiply both sides by y. Both sides by y. So the y will cancel here. So you only have dy dx on the left-hand side, and it will be, and you replace y equal to x to the x, and then you have all in terms of x. So do another one, x cosine x. Maybe I'll do that one during class because it's very similar to the first one. Let's do one where I have x squared sine x over 2x plus 1. I'm going to do dy dx. It is quotient rule. But then the top is really difficult. Right? So if I do f equal to x squared sine x, when I do this part, it is a product rule. So it's just really complicated. So if we run into things where we have a lot of product multiplying together, we would rather do logarithm differentiation. So let's try ln y, add log on both sides. You have to add it to use it. So why do I do that? Because if you have a lot of things multiply, after you add log, you can change it into add. This looks like the one that we have done before, right? So now before we do anything, we'll say ln y still, and I'm just expanding this. This would be ln x squared plus ln sine x. Do you recognize that we did it in the last video? Plus, oh no, this is minus. Because I'm subtracting. I'm dividing. ln 2x plus 1. Can I simplify more? The x squared becomes 2 ln x. Expand it until you have only one thing in ln. Plus ln sine x minus ln 2x plus 1, and the whole thing is ln y. Now when I do dy dx, both sides, you can see that the left-hand side is always the same. So this would be 2 over x, and that one would be 1 over sine x dy dx of sine x, because this is the inside. Whenever you have something that is inside of the ln, you have to do a derivative. Minus also 1 over 2x plus 1. Also do a derivative of it. 2x plus 1. So continue. So this would be 2 over x. Oh, this side would be 1 over y, ln y. No, 1 over I, dy dx. The reason why is we're going through the same step as we do here. I will change it into dy and then dy dx. So and then when I do the derivative, it's 1 over y dy dx. So if after I do a few times, I know that if I do d dx of ln y is 1 over y dy dx. Plus derivative of sine x is cosine x over sine x. Plus, minus derivative of 2x plus 1 is 2, and 2x plus 1. So then it would equal to what? This. But I want dy dx only, so I multiply y on both sides. Dy dx will be y, which is this whole thing that we have. X squared sine x over 2x plus 1. And then the one that we have here, 2 over x plus cosine x over sine x, which is cotangent x, minus 2 over 2x plus 1. You don't have to multiply, so this is the original y. Okay. We'll do this in class. Oh no, we'll do this here. So let's do it here. One more time. Take ln y, take ln on both sides, and then ln sine 2x, 4x. Again, ln of this, the 4x can move to the front. ln y equal to 4x times ln 2x. ln sine 2x. I added ln, so ln sine 2x. So then I need to do dy dx now. So dy dx of ln y and dy dx of this product rule, f equal to 4x, g equal to ln 2x, f prime equal to 4, g prime would be, oh no, not ln 4x, ln sine 2x, ln sine 2x. So this is a composite function. Inside is sine 2x, outside is ln. So 1 over sine 2x, and then the derivative of sine 2x, which is cosine 2x, and then a derivative of 2, which is, we do a little bit more space. Oh, do I have more space? No, not enough space. Where am I? Oh, here. Ran out of space. So maybe I'll write it again. So g prime would be 1 over sine 2x. Do the derivative of sine 2x, which is cosine 2x. But there is a 2 here, so it times 2. Right? So it'll be 2 cosine 2x. So this would be 4 times this. 4 times ln sine 2x plus GIF. This is 2 cosine 2x times 4x. So it'll be 8x cosine 2x over sine 2x. So that's the GIF part. 4x times the top, which has 2 cosine 2x times 4x, so it's 8x. So that is this side, and the other side would have 1 over y dy dx, right? Whenever you do dx of ln y, that's it. And it will be equal to these things. And so just rewrite it again. ln, oh, I should say d dx. 2x plus 8x cosine 2x over sine 2x. Okay, and then dy dx would be multiplied by y on both sides. So what is y? Y is these things that we have. Sine 2x to the 4x, and then just copy this over. It's really long, but we did it. Okay, and the last one we'll do it in class. We'll have one more videos on application.